Good afternoon, this is Schweitzer, and this is a short little video about how to use our solubility chart. Now, our solubility chart is often used in honors chemistry or advanced chemistry to determine whether a substance is soluble or not. Now, in this situation, whether something is soluble or not really is not like a yes or no question. We will deal with it as sort of a yes, or a no situation, but in reality, it's something in between these two things. This particular chart is only going to deal with ionic compounds, and therefore, marker's a little bit slow here. Okay, so we have a cation and we have an anion. And to determine solubility, technically you would want to do, you need both items. We have, let's say, for example, NaCl. These substances are attracted to one another, and whether they separate is dealing with both of them. We have water molecule that has obviously a partial charge on it. It is partially positive, partially negative. Here's my partial positive, here's a partial negative. Of course, not a full charge. Would use a little partial charge here to show that, but obviously the attraction here is called an ion dipole reaction. This actually is the negative. That would go over to this side, so we'd have a chloride here, Cl minus, and the Na would be on this side, and Na plus would be over here. So anyways, both of them matter, okay? So how does this chart work? Well, first of all, before we get too far along lines, you should have this chart in front of you, and on the bottom we have what I call our quick checks. So with an ionic compound where we have our cation and we have our anion, if any of these guys are present in either of them, then this thing is going to be aqueous. These are things that are very, very soluble. Doesn't matter what the corresponding ion is, it's going to be soluble. So if you have an Na in the substance, Na, then the anion, it doesn't make a difference. It's going to be aqueous. K plus. Okay, so we're always doing ionic compounds. Doesn't matter what the ion is, it's going to be aqueous. If we have a nitrate as an anion, it doesn't really matter what the anion, the cation is, it's going to be aqueous. And if there's an ammonium in here, it's going to be aqueous. Okay, doesn't matter the anion. That's our quick check. So this is something we could easily check over and see when we're looking at a solubility reaction as to whether or not we have a precipitation or not. So the way this chart works is, let's just do a quick little example. Let's say I have a reaction that produced AgCl and KNO3. Okay, so first thing I do is my quick check. Do I have one of my quick checks present? You'll learn these up pretty quickly. Oh, there we have a potassium and a nitrate, so just need one of them. It would be fine, but we have both. So I put an aqueous here. That means dissolved in water. Okay. Now what about this one, AgCl? So for this guy, we use our chart. There's no quick check present. This particular chart works off of the anion. Now for AgCl, this is my anion, and this guy is a chloride right there. So look for the anion in this list. It's going to be here someplace. It's not a 100% comprehensive list either. So it's just generalizations. So not everything. Chloride. So what we would do here is, okay, what are chlorides? This sheet works mostly off the anions, are mostly soluble. So in general, chlorides are pretty soluble. There are some exceptions, which makes them insoluble, forming a solid. Take care that I've added these guys because this is the notation we'll use. All right, well, what are the exceptions? Well, the exceptions are located right here. Now, the exception is going to be if we have Cl minus, what is this guy out front? What's the cation? Well, if the cation's silver, mercury, and there's some other individual exceptions as well, then this thing is not going to be aqueous, but instead it's going to be solid right here. So there we go. Because it's an exception to most chlorides, it will be S or solid. And all the other information that you would like to know about this would be about the reaction itself. Will be covered in class or in other videos, but just how to use this chart, that's it. So, for example, if we have, say, barium, this is an unusual one, barium hydroxide. Now, again, this is just this is just an example, right? So, hydroxides typically are insoluble, S, and they mostly form solids, unless, of course, you have one of these exceptions, which this is, and therefore it's aqueous. And that's all I have for you for on this chart. And from there, you should be able to run it pretty good after that. Thank you.